Fbx export. So here's our character again. And we have a new option in the File menu to export Fbx. What is Fbx? Fbx is a 3D interchange format. So it's a file format generally used for 3D files, and it's supported by a wide variety of software. Unity, in particular, is what we've been targeting with our Fbx export. Unity is a game development environment. So not all Anime Studio users are game developers, but I think there is a subset that might be very interested in the possibility of it. We can now export Anime Studio files and import them into Unity. Fbx files can also be imported into other 3D applications like Maya, 3ds Max, Cinema 4D, and Poser. And Anime Studio at its heart really is sort of a 3D program. We can look at things from 3D. Here's the camera, here's the character. Many scenes in Anime Studio happen to be flat, but they don't have to be. There's actually a reasonable compatibility between Anime Studio and these 3D programs. So how does it work? Well, I'm going to show you this character a little bit. This character, I don't know if I played him back before, but his default animation is to walk across the screen. He also has some actions set up here. He has a jump action and a kick action. So just some simple animations on this character. And all I'm going to do is I'm going to say export Fbx. So I'm going to save that where I want my Fbx file to go. And as it's saving, I'm going to bring up Unity. So here's the Unity game development environment, just sort of a blank project right now. We've got a timeline and a content region. So let's see, Anime Studio is done exporting. I'm going to take that Fbx file, here it is, and let's hide Anime Studio. This is the Fbx file created by Anime Studio. If I drag it into my assets in Unity, here's the character. Now you'll see he looks a little weird in this view. By default, Unity hasn't brought up one of the animations, but if I expand the character, we can see a lot of different parts in here. Here's his body as a 3D mesh, an ear. None of it looks very interesting. The part that is interesting is if you look down here a ways, you see the animations. So here's his mainline animation if I bring him into the proper view. If I can play that back, here he is in Unity animating. And this is not just a rendered movie. This is the body parts are there. The animation is actual 3D parts moving around. There's also the kick animation and the jump animation. So these are all here in Unity. Unfortunately, I'm not an experienced Unity user, so hooking these up to a full game environment with joystick controls and stuff is beyond me, but we've talked to some people that have shown us how to do it. It's just a little more involved than I want to get into in the webinar here, but you could create an animation where the character is walking along, and then by pressing a button in the game environment, he switches over to his jump animation. Or the kick or whatever, and you can bring in multiple assets this way and map them to a game environment. Again, because it's 3D, you can actually position stuff in 3D in Anime Studio, so I don't really want to go into that too much, but I can rotate the head at a weird 3D angle here, put perspective on things, and all that translates into Unity as well. So it's sort of our first pass here at Unity Fbx output, and we want to see what kind of games people can create. I've got a couple other things I'm going to show about this, but I think we may have some questions too.
Actually, it's just a quick statement.
Yeah.
One of our beta testers was on the line attending the webinar, William, and he mentioned that he was able to take the Fbx output and import it into Unreal 4 engine.
Great.
Use it there. So,
awesome.
yeah.
So we'll put that on the list too.
I think there's a question.
There is one more question with FBX. Is the FBX a polygonal mesh?
Yes, it is.
And does it come with its own texture map?
Yes, it outputs actually multiple polygonal meshes, one for each vector or image layer, and they're texture mapped. The texture map is included in the FBX file, so it's a self-contained file at that point. This is also about FBX that I'm going to show here. Many things are supported, not everything is supported when we output to FBX, in particular point binding. So when we output vector layers to FBX, we actually output them as if they were an image. So we create a little 3D mesh around the vector layer and texture map it with an image of the vector layer, not the actual vector shape. And that's because for game purposes, it would be too complex, too big a hit on memory and performance and everything to output all the vector information. So that means vector-specific features do not get exported to FBX. So point binding, point animation, lines or stroke width and curvature animation, none of those get exported to FBX. So you have to sort of imagine your vector layers as if they were image layers. So you can draw your vector artwork, but then don't animate it during your animation if you're intending to output to FBX. So we have a little sort of helper feature in Anime Studio for this. So here's a character that uses point binding. And if I outputted this to FBX, it would not look the way it does here in Anime Studio because point binding isn't supported. But I can go to the View menu and select Fbx Preview Mode. And what that does is it looks now how it would in an FBX supporting application like Unity. And so point binding is disabled. Point animation, if there were point animation in this project, would also be disabled. And you sort of see what it would be like without having to go through the export, import, test process. And this doesn't actually change your project. It just temporarily disables the features that are not supported by FBX export. So that'll be a helpful thing when working with FBX. I would recommend not just taking any existing Anime Studio content and outputting it as FBX. It sort of takes some thought in how you set up your project. Really the key thing to keep in mind is if you use image layers, everything should be fine. If you use vector layers, just sort of treat them as if they were image layers and don't animate the points, don't bind the points, nothing specific to any vector point.